right. Hi, class, and welcome to 5.2b lesson. This is going to be a short lesson, but it's going to be similar to 5.2a, where we talk now about the volume of a cone. Okay. You could see and imagine that the cone's volume is somewhat similar to the volume of a cylinder, but the question is, how similar is it, right? Right now, the instruction is to draw a cylinder and draw a cone. And let's see how we can compare the two, right? So a cylinder, again, is a circle that has, obviously a radius and it has a height. We know that the volume of this cylinder is pi r squared, the area of the circle, times the depth, right? The height of the object. Well, let's write this r. So we also know that a cone could potentially have that same circular base, right? So you might have to calculate the area of a circle still, but it doesn't nearly have the same volume, right? Because it kind of gets smaller and smaller, and you can kind of see that, right? The circles kind of dwindle in size to the point where they eventually meet at a point. So, what is the volume? What do you think the volume is? Does it have anything to do with pi r squared h? Right? So, I'm going to leave that up to you. What do you think that is? How many cones of water are needed to fill the cylinder? So, we're going to watch a quick video in class, but spoiler alert, the truth is a cone with the same exact radius and the same exact potential height of an alternative cone. I'm sorry, cylinder. A cone with the same radius and the height of a cylinder would actually fit inside that cylinder approximately 3 times. Okay, how many cones of water are needed to fill a cylinder? Approximately 3 cones fit in the volume of a cylinder, right? Obviously, if it has to have the same dimensions. What fraction of the cylinder is filled by the volume of one cone? So 1/3 of the cylinder is the volume of the cone. And that leads us to the formula. How does the equation for the volume of a cone compare to the equation of the volume of a cylinder, right? We said that this is the volume of a cylinder. The volume, I'm going to write volume of cone, is going to be 1/3 pi r squared h. Isn't that amazing, class? How is it actually 1/3? If anything, when you say that I had a cone that could fit into this cylinder, it's only 1/3. It looks like half, but really, this is an optical illusion, right? And I know it looks like half, but as you realize as you go down the cone, the volume of the second half of this cone is really really small, right? So it's kind of it's interesting how it's 1/3 exactly, but that's just the magic of math, right? So once you know this new formula, I think practicing how to calculate the volume of certain cones is rather easy. Again, write down the given information. We know that the height here is going to be 8 feet. We know that the radius here is 5 feet. So we just have to plug it into our formula. And obviously use your calculator. 1/3 pi, which is 3.14, r, which is 5, squared times 8, the height, is going to give us the volume of this cone. So obviously calculate 5 squared first, which we know is 25, and then multiply it by 3.14, and I get 78.5, right? And once I get 78.5, I then am going to multiply it by 8, and then divide this by 3. and I get roughly 209.33. So depending on what the instructions tell you to do, obviously you can round to the nearest tenth. Oh, it says to round to the nearest tenth. So I'm going to write this as 209.3, and you write feet cubed. Now you can put a bar on top if you want, but it was an approximation anyways. Now, the reason why it was an approximation anyways is because pi itself was already an approximation. Okay, let's go ahead and try number 3, right? So the radius is going to be 20, and the height is going to be 15. Be careful that you don't accidentally flip the 2 dimensions. It would be unfortunate if you said that the radius was 15 in this case, when the radius is actually 20, right? So 1/3 3.14 times the radius, 20 squared, times the height, which is 15. And this is going to give us 20 squared is 400. 400 times 3.14 is 1256 divided by 3, 418.6 times 15. It gives you a solid 6,280 centimeters cubed. Again, it's an approximation. So, does anyone enjoy plugging in values into a formula and into a calculator? Right? Once you know the formula, once you kind of remember and memorize the formula, it's not too bad. All you need to do is have your calculator ready. All right, last one. A cone with a diameter of 9 meters. Be careful here. You're giving us the diameter, and we need the radius, and then the height of 4.2. Okay, so when I read this, I don't really want to write D equals 9m. I'm just going to write R is equal to 4.5m. That's what we need from this context, right? The height is going to be 4.2m, and again, my volume is 1/3 pi r squared h, which is going to be 1/3 times 3.14 times 4.5 squared times 4.2. So these numbers are really, really technical now. They're decimals all over the place. Really no way you can do this mentally. So just check out. Now, when you have a scientific calculator like this, we probably won't be allowed to use something like this until high school, but 4.5 squared equals 20.25 times 3.14, right? Times 4.2, and then divided by 3. I'm getting 89.019, which is approximately 89 meters cubed. This lesson is kind of short, but I think this was a good introduction to cones. We have another page to go, and I will let you practice that in class. So thanks for watching, everyone.